We are doing solution part and we have already completed it. Numericals based on solution part. When I started mixture, then I told you there are two types of mixtures, homogeneous and heterogeneous. In homogeneous example I have taken solution, and in heterogeneous colloid and suspension. So today we will discuss all these and the differences in them. First of all, I will start with solution. Here I have written properties based on which we will differentiate solution, colloid and suspension. So it is difference also, and there are properties or characteristics of solution, colloid and suspension also. I have taken this sharbat to take the example of solution to make it clear for you. Solution is any kind of mixture which is homogeneous in nature. Homogeneous means particles completely mixed with each other and we cannot separate them. Okay. So to check that all these properties, I took this. This is what? Solution. How can you say that it is a solution based on these properties? First, nature. What is the nature of this solution? It is homogeneous. Homogeneous means we cannot see the particles of two substances in it. Water is not separated here and juice is not separated here. Completely looking like same everywhere. So it is homogeneous in nature. Second one, particle size. What is the size of its particles which are making this solution? So these particles are very small because we cannot see them with naked eye. So these are very small and their size is about 1 nanometer or less than that. What is nanometer? Nanometer. N for nano, N-A-N-O, and M for meter, M-E-T-R. 1 nanometer is equal to 10 raised to power minus 9 meter. That means if we divide 1 meter by 10 raised to power 9, then it will become 1 nanometer. So you can imagine that it is very much less than a meter. So the particle size is very, very small. Next, appearance. It is clear and transparent. You can see fingers here and even you can see board also. In home also you make this type of solutions. You can take sugar, salt or any clear thing to make solution, and after that study these properties. Okay, so this is clear and transparent solution. Separation. Separation means how can we separate the particles of these two, water and this juice? It is not done. We cannot separate now the particles of these two. So separation is not done in case of solutions. Stability. Stability means when I make this solution, if it remains like this after 1 hour, after more time, then it is stable. But if its particles get separated at its own, it is not stable. So this is same. So it is stable solution. Particles visibility. That we can see the particles of solution or not. So we cannot see them by naked eye or by microscope. It is all looking like same. So particles are not visible in this solution. Tyndall effect. Tyndall effect we have done in first chapter also. Tyndall effect means when we pass light through the solution, then we can see it through or not. Let's check it. So I will pass light here and show you. I pass this light. Inside the solution it is not shown, but outside the glass you can see it on hand. That means when we pass light from one side, it directly seen at the glass tank, not inside the solution. Why this happens? Because particles of solution are very small. This is solution we have. When we pass light, if particles are very small, then what happens? Light directly pass without touching them, and we cannot see it inside. Only outside we can see this. That means this solution not showing Tyndall effect. If light is shown inside it, then it is called Tyndall effect. Tyndall effect simply scattering of light by the particles of a mixture. So here particles not scatter light because their size is very small. So Tyndall effect is not shown here. Next is Brownian motion. Brownian motion is zigzag movement of particles. Means particles of solution when strike with each other or with the walls of container, then they change their direction and go in any direction. There is no specified direction that they have to go straight. They can go in any direction, and this is called zigzag motion. So in solution also, due to small size of particles, Brownian motion is also not shown. Electrophoresis. What is electrophoresis? Electrophoresis is movement of charged particles or movement of particles due to charge. Here we are taking positive and negative charge ions or particles. In solution, electrophoresis is not shown. Last one, charge. Electrophoresis is not shown because no charged particles are present in solution. Is it clear? Okay. Now we will start next colloid. What is colloid? Colloid is also known as a sol. Now see the difference. When I told you you have to write the solution, then you have to put a dot after SOL. This dot is compulsory. If you are not putting dot here, then it will become sol. So sol and solution both are different things, and there are lot of differences between them. Okay. So this is sol or colloid. Colloid, few types I will tell you in next lecture. This time we are just taking these properties. For colloid, I have taken the example of milk here. In milk, I am adding here water, so making mixture of two things, milk and water. See this. Now it is example of colloid. I have written more examples also. Soap lather is also example of colloid. Clouds, fog, smoke. These all things are examples of a colloid. So what is this? Colloid is heterogeneous in nature but appears homogeneous. Means when we see milk, it is looking like completely white. No other particles are seen in this. But we know fat particles also there, different type of sugars, proteins, etc. are there. So all these particles are mixed with each other. And when we boil milk, after that cool it, then we can see these particles, fat particles in the form of droplets or milk cream. Okay, so that time these particles separated. So it looks homogeneous, but actually it is heterogeneous. Next, particle size. Its particle size is greater than solution particles. Solution particle is less than 1 nanometer. And colloid particle size is from 1 nanometer to 100 nanometer. It can be 2 nanometer, it can be 99 nanometer, or it can be 100 nanometer. So from from 1 to 100 nanometer particle sizes of colloid. Next, it is translucent. Sometimes it appears opaque also. And when we will add more water, then it will be translucent. Next, separation. It cannot be separated by a simple filtration technique. When you take hot water, hot milk, after that you filter it. What happens? Cream is not separated from the milk. Or we can take other examples also. In other examples also, filtration technique in which we use filter paper or sieve, it is not possible to separate the particles. But a special technique, centrifugation, is there. In that technique, we rotate the mixture at a high speed. It is done in washing machine also to separate mud particles from clothes. So in detail we will do next lectures. So colloid can be separated by centrifugation, not by filtration. Next by stability. These are simply not stable. But when we add some chemicals, they are called stabilizers, then they become stable. Stable means then their particles will not move. We can see its particles with the help of a microscope. If you will put drop of milk under microscope, then you can see fast granules there. Next, Tyndall effect. Tyndall effect is shown in case of a colloid. Let's check it. I am passing here light. You can see this light inside milk also. From inside also milk is showing light. Okay, see this. And in the last, at my hand it is not clear, but inside the solution this light is clear. See this one. It is not shown here, but shown inside this mixture. Next is Brownian motion, movement of particles. So particles inside this move because the particle size is more, they scatter with each other and regularly shown a movement. Next one, electrophoresis. The particles of colloid contain positive and negative charge ions. Due to that, they show movement. So electrophoresis is also there and positive and negative charges are also there. It was all about colloids. Now, last one is suspension. Suspension is made from suspended wood. Suspended wood means suspend in the solution and not settle down. For this, I am taking example of soil and water. See this. I mix soil with water. This is a kind of this heterogeneous mixture. You can see at the bottom it becomes dark and at the top it becomes light. That means separation of particles starting. It is heterogeneous in nature. Its particle size is big. That's why we can see particles of soil inside the mixture. And its particle size is greater than 100 nanometers. It is opaque. When made, it is opaque. That means we cannot see through them. Its particles can be separated by simply filtration technique. By using filter paper, we can separate it. Or in homes, to clean water, in all the time, we use some kind of cloths to filter water and to separate soil particles, etc. So by filtration, we can separate them. These particles are not stable. You can see here because suddenly they settle down at the bottom. So this is not stable. When we made this, it is like this. Particles were inside it. But after some time they settle down. Its particles can be seen by naked eye. There is no need of microscope to see the particles of soil inside it. We can see by naked eye. Next, Tyndall effect is also shown by this type of solutions. See, inside this mixture, light is shown. Particles are seen very clearly that they are showing here a Brownian motion. So, Tyndall effect as well as Brownian motion both are seen inside suspension. Next is when particles settle down at the bottom, after that Tyndall effect not shown. Electrophoresis is not shown because particles settle down, they not mix properly and they not form charges, so there are charges are also absent. So these were the characteristics properties of a solution